Hello, my name is Macy Anderson, and here's my Lab 2 for Physics 2212 at Georgia Tech. So the purpose of this lab was to compare the electric force of a point charge model to that of a line of charges model using the tape model from Lab 1. So in Lab 1, we calculated the point charge of a piece of tape. And in this lab, we essentially used the same tape, but instead of modeling the tape as a single point charge, we split it up into many small segments and then found the charge of the tape that way. And so we did that using GlowScript as our computational model. And our system was the floating piece of tape. The surroundings was the bottom tape below it. And just as a preview of my results, I found that for the point charge model, the charge on each tape was 3.27 times 10 to the negative 8th coulombs, and in the line of charges model, the charge on each tape was 4.314 times 10 to the negative 8 coulombs, so a little bit different. So what fundamental principles were used in this lab? Firstly, Newton's second law, which states that a change in momentum is proportional to the net force applied, or F net equals final momentum minus initial momentum divided by change in time. Coulomb's law, which describes the force of attraction or repulsion between two electric charges, which are either positive or negative. And gravitational force, which is the attractive force between any two objects with any mass. So just to review my Lab 1 initial conditions and results, my tape length was 0.2 meters, my tape mass was 2 times 10 to the negative 4 kilos, and the tape width was 0.02 meters. And if you look at the right, this is the computational model that I got from Lab 1, which found that the charge on each piece of tape was 3.268 times 10 to the negative 8 coulombs. And the force of gravity and the electric force balanced each other out. So for Lab 2, I first calculated the gravitational force, which was the same as in Lab 1, which will be 0.00196 newtons, and the electric force is equal to the force of gravity in this model because the tape is floating, so the force above it and below it must be equal. And then I was able to solve for the charge by using the electric field of a rod equation, because if we're splitting up the tape into a bunch of small segments, it'll essentially look like a rod would, and so the electric fields would be similar. And by plugging into that equation, with R being the distance between the two tapes, or 0.07 meters, and L being the length of the tape, which was 0.2 meters, I found the charge to be 4.314 times 10 to the negative 8 coulombs. So here's my computational model in GlowScript for this lab. I plugged in my conditions on the left and then edited the electric field equation as shown on the right, and there's the programming that I used. And then here's the for loop that iterates through each piece of charge in the piece of tape, because essentially you calculate the point charge of each little segment and then combine it all to get the overall charge of the piece of tape using this model. I had in my model 50 segments for the tape, because ideally the more segments you have, the more accurate it's going to be. So here are my results. As you can see on the right, this is the model that was generated through that code. And it shows that the electric field and so the electric force and the force of gravity are roughly equal, with the magnitude of the electric force being 1.674 times 10 to the negative 3, and the gravitational force being 1.962 times 10 to the negative 3. So they're fairly similar, not entirely similar, but mostly balance each other out. So for this lab, the assumptions I made were that air resistance and friction can be ignored. Each tape has the same charge, and the charge is uniformly distributed across each piece of tape. Potential errors are that I could have made imprecise measurements when doing the physical model in the last experiment. I could have had a loss of charge due to contact with my hand or the environment, and I may have calculation errors. So just for further discussion, what if I had modeled each of my tapes as a single point charge like the previous lab? So as we can see in the point charge model, I found the charge to be 3.268 times 10 to the negative 8 coulombs, and in the line charge model, I found it to be 4.314 times 10 to the negative 8 coulombs, so it was a little bit bigger in the line charge model. And why did they differ? The difference is due to the different level of precision in calculating the charges. When you have more segments, you're more accurate to the real world and is closer to the real value. So that accounts for the difference and also accounts for the reasoning as for why the point or the line of charges model is more accurate than the point charge model. Thanks for listening.